Now, let's welcome Dr. Qiao as he will present his thoughts on efficient energy use and conservation, smart city, and more.
Among the top 10 problems for the next 15 years, energy is the top one. The foreigns of water, food, and the environment. All of these three problems are also strongly related to energy. Let's take a look at the energy landscape in Hong Kong. Among the final energy requirements, around 50% is for electricity. The rest are for oil and gas. All of these energies are generated by coal, natural gas, or nuclear power. Because of the using of fossil fuel or nuclear fuel, that will bring a lot of environmental issues, such as global warming, air pollution, and nuclear pollution. To solve these environmental issues, a lot of countries around the world are trying to achieve carbon neutrality by 2050. This is the so-called Paris Agreement on climate change. Of course, Hong Kong is committed to take actions under the Paris Agreement. In 2017, Hong Kong released the Climate Action Plan 2030 Plus and committed to peak carbon emissions by 2020. To achieve that goal, we need to partially or fully replace the current fossil fuel or nuclear fuel using sustainable energy. So there are two reasons why the sustainable energy is the best candidate here. First, sustainable energy is one of the safest energy sources. For instance, 1 terawatt-hour sustainable energy only causes 0.02 deaths. That is 920 times lower than the oil. Second, 1 kilowatt-hour solar energy only brings 5 grams carbon dioxide. At HKSPA, we contributed to the Climate Action Plan by setting the strategy of sustainable and smart campus. Here now, more than 8,000 solar panels have been installed in 50 locations across the campus. For our lab at HKSPA, we are engineering the energy-related properties of materials from atomistic scale to macro scale. We are trying to design the materials using atomistic defects, locations, green boundaries, and the grains. And of course, we're trying to design the energy properties of the device directly. Why the multi-scale engineering is so important in designing the advanced energy materials? Let's first take a look at the lithium batteries. By using the nanotechnologies, we can improve the capacity of lithium batteries by 10 times. We can also improve the energy conversion efficiency of thermoelectrics by 100 times using the nanostructuring. And of course, we can improve the heat dissipation efficiency of the chips in the data center based on the multi-scale engineering technologies. Today, I'm going to show how we contributed to the sustainable and smart campus, city, or even the world by showing two examples. So the first example is about how to improve the energy conversion efficiency of thermoelectrics using nanotwin. The traditional concept to improve the energy conversion efficiency of thermoelectrics is to decrease the thermal conductivity. However, it will decrease the power factor at the same time. Of course, if we increase the heat coefficient or the energy conversion efficiency somehow, for instance, from 1 to 2, but however, here, obviously, this is not the best idea. So the best idea is trying to decouple the power factor and the thermal conductivity, and then maximize the energy conversion efficiency of thermoelectrics. In our lab at HKSPA, we are trying to using the nanotwin to decouple the thermal transport properties and the power factor. By using such a kind of strategy, we can decouple the thermal transport properties and the power factor, and then enhance the energy conversion efficiency from 0.03 to around 0.5. This is the first example. My second example is about how to cool down the solar panels using a sustainable evaporative coating. One of the biggest challenges for the solar panels is overheating. The traditional way to cool down the temperatures is using active cooling by water. Of course, it can cool down the temperatures of the solar panels by tens of degrees. However, it consumes a large amount of water and energy. In our lab at HKUST, we propose a concept by using the sustainable and smart coating. A coating can absorb atmospheric water at the low temperature and evaporate these absorbed atmospheric water at the high temperatures. By utilizing this cycle, we can then cool down the temperatures of the solar panel. Our preliminary results show that a coating can cool down the solar panels by 5 to 10 degrees at the low relative humidity, such as 30%, and the high relative humidity environment, such as 17%. In the future, we are continuing to contribute to the sustainable and smart campus, city, or even the world by using the multi-scale engineering technologies.